In this video, I will show you how to do a forecast using a regression model. So what I have done is this. I have I opened the Coca-Cola sales data, the same file we have used in the class. This sales data consists of two variables, the quarter and the sales value. I think we have done that in class. There are around 42 sales values. So before we do anything, as I have done in class, I'm going to add a few columns. So the first one thing I will add will be time t, and it is just 1, 2, and so on and so forth. So it's just a sequential numeric identification of the different data points we have. So this shows that we have 42 data points. The other thing we will do is we will have a log value of sales. If you remember, in the class we thought of considering an exponential model, and to do an exponential model in the regression setup as an additive model, we have to consider the log of the y, and the y here is sales. We also talked about that there are two types of log. The ln is the natural log, and that's what we should consider. The log in Excel represents the log of base 10. Since we want to deal with your natural log, then you should also consider just ln as the function to compute log values. Apart from that, we will also create a 4-quarter identification. So I'll say Q1, Q2, Q3, and Q4. It identifies the quarter for which the data represents in that particular row. So Q1 it will be 1 for the quarter 1 and the year 86, 0 for Q2, 0 for Q3, 0 for Q4. Then in the Q2 86, there will be a 0 for Q1, 1 for Q2, 0 for Q3, 0 for Q4. Same thing with quarter 3, it will be 0, 0, 1, 0. And quarter 4, it will be 0, 0, 0, 1. And now, to make it, to move things quickly, I'm going to copy these 4 values, and I'm going to just paste them. So in that way, we create these 4 dummy variables. These dummy variables will be later used to control for seasonality in the data set. Just making sure there is no missing values, and that's about it. Okay, so we start with the Coca-Cola sales data, and we added 6 new variables. Time t, which is an identification of the observation in sequence, so 1 to 42. The log sales, this is done so if we want to do an exponential model for forecasting, we have to do a log sales. And then I have added 4 columns, each identifying the quarter for which the data is in that particular row. So the first thing we will do is do the partition this data. Now our goal will be to forecast the next 4 quarters. So our goal will be to forecast Q3 96, Q4 96, Q1 97, and Q2 97. So since our desire and the goal is to predict the next 4 quarters, we will do a partition, and we will make sure that the length of the validation is around 4. Now, as discussed in class, now there's a time variable here. I can use both the time t or quarter for the sake of simplicity, and it says that there's some quarter has missing values. So we have to make sure when something like this happens, we want to make sure the data range it consists of only the rows and the columns where there is information. So it says that the data range for sheet 1 is A1 to H44. So let's go and see if the data set has anything for H44. It does not, right? So looks like our data set ends at 43. So what I will do is I'm going to click somewhere in a cell where there is some kind of data, click on partition, and now you can see on the top that it says H43 and not 44. So if I select quarter as my time variable, um, then obviously there are many things we can do. So we have the quarters, and we're going to create the rest into the move the rest into the variables in the partitioned data window. Now, as I mentioned, we're going to specify the number of records we want for validation and training. So we want 4 in validation. So there are 38 in the training set, 38 observations in the training set, and 4 in the validation set. Now, we can obviously have more than 4 in the validation. The only criteria is to have at least a reasonably and efficient comparison of models. We should have variables at least same length as one you would get in our required goals. So the goal here is I want to predict the next 4 quarters, so you should have at least 4 in the validation set. So I'm going to click OK, and as soon as I click OK, there's a new spreadsheet called Data Partition TS that's formed. As the previous video showed you, if you click on the training, it's going to highlight the data in the training set. If you click on the validation, it's going to highlight the validation set data. So before we move forward, let's just plot this. Let's just plot this data set and see how it looks like. And we have done this in the class, but I want to kind of repeat this process. So I will just go to insert, and I'm going to do a line plot, and it looks like this. I mean, it really looks like this. Now we can remove this quarter stuff. So we have sales over time and so on and so forth. Let's also plot the log sales over time. So I'll select another data set, add series name is log sales, and I'm going to just select this, and so click OK. I'll also remove the sales because it's already scaled. And as you can see, the same, nothing changes except the y axis values change, but the structure remains the same. Okay, almost similar. So the next step we will do is let's develop a model, and as we have done in the class, we will first develop a predictive model with just time t. So I will go to multiple linear regression. Okay. And remember, the goal here is that I'm fitting a linear model, and the assumption is that the trend is a linear trend. So my y output is sales, and my x would be time t, and I am not considering any seasonality at this point in time. I'll do next. I'll click on fitted values on the top, and then I will select detailed reports under score training data window and detailed reports under score validation data, and then I'll click finish. As I click finish, there are a couple of things you want to make a note of. For example, in the spreadsheet MLR, which stands for multiple linear regression underscore output, you should make a note of the RMSE value under the validation data scoring. And this is 591.55, and that is for fitting a linear model. So how the linear model fit? Let's see. If you just select these two particular rows and you create a plot, you can see that it just draws a line across the actual value. Now, obviously, this looks great, but obviously we can see that there is a lot of difference between the actual value and the predicted value. As a matter of exercise, you should also select residual and make a plot of the residual. In this way, you will have an understanding how the error looks like. Now, as you can see, an error should be random. But this plot of the residual shows that it is not random. There is some component of seasonality still left. So the next step for our case will be to include the seasonal components. Now, in our case, we have already created 4 dummy variables, Q1, Q2, Q3, and Q4. So what I will do is I will go to the predict, click on multiple linear regression as we have done. My DV is sales and my IV would be time t, and 3 of the 4 variables, dummy variables. Remember, given that there are 4 quarters and we have 4 dummy variables, if we know the information for the first 3 dummies, we can easily deduce the dummy values for the 4th one. So therefore, if we add the 4th quarter, we will be over specifying our model. Click on next, and then we will just select the same boxes as we have done in the previous exercise, and we'll click finish. So as you can see here, this output is 464.98, the RMSE of the validation, which is obviously less than the one we had earlier on. Remember, the earlier on our output was with only a linear model, the RMSE was 591.55. Now when we included the dummy variables for the seasonality, it is 464.98. So let's look at how the plot looks like. Okay, so I just selected these 2 columns and I say insert, say give me a line plot. It's pretty nice, pretty close. Let's also look at the residual plot. Select the residual, click on this. So what you see here is there is some kind of a curve here, right? Although most of the seasonality has been taken care of, but this residual is not random, but there is some kind of a curvature that goes into it. So what we can do is, as I've done in the class, we will develop an exponential model. And in this case, we will develop an exponential model with the seasonality components. This is just a bit different than what I've done in the class. In the class, I built the linear model, then I go ahead and build an exponential model, then I built an exponential model with the seasonality components. In this video, I am starting with a linear model, then I have already ran a linear model with seasonality, and now I am going to develop an exponential model with seasonality. So the only difference here will be the dependent variable. Instead of looking into just sales, we will be using log of sales. We already have the variables, so I will make sure that my it's identifying the correct spreadsheet. So as you can see here, this log sales, it will be on the output variable, and my input variables would be time t and up to Q3. I select on next, detailed reports and fitted values, and I click on finish. So RMSE obviously is 0.049, which really makes no sense given the and this value is low because we have already log transformed our dependent variable. So therefore we have to kind of transform it back to in dollar amount so we can really compare the three models. So what we should do is to do that we have to go to the validation sheet, because what we have done in for the previous models, we actually are comparing the RMSE for the validation data set. So to develop an RMSE for this particular data set, what I will do is first I will kind of convert it back to exponential. So actual values, predicted values in exponential, it will be equal to EXP and the value. And so this is the value in dollar amount. Okay. And then this is the value in the actual value in the dollar amount. Between these two new variables, I'm going to calculate the error, which is nothing but equals to actual minus predicted. Then we'll do an error squared, which is nothing but error times error. So P16 times P16. P16 times P16, and then making sure that they are squared, and I'm going to look at the sum of these values divide by 4, which is the number of observations, and then we will take the square root XQRT of this value. There you go. So the RMSE, this is equal to RMSE for exponential model. So what we have here is this is my RMSE for the exponential model, which is obviously very different and smaller than the other values we have, right? So that's what obviously, so this shows that an exponential model with seasonality may be the best fit. So let's look at the plot. I mean, it's always good to plot them and also plot the residuals. So let's try to plot the predicted and the actual values in the training set. Obviously the plot is very close to what the linear model with seasonality did. But let's look at the plot for the residuals. Maybe there is no trend anymore, which was what we were concerned about in the previous plot. So as you can see, there is no curvature into the residual plot. So obviously having an exponential model with seasonal dummies was a very good idea. So the last thing we will talk about in this video is to predict the next 4 data points. To do that, I'm going to create a new data set. I'm going to take the variable names, and then I'm going to copy this variable names. I'm going to create a new data set here, and I'll name it as, let's say, a forecasted data set. So obviously this data set should not have any sales values. So I remove the sales values together. So the next 4 quarters will be Q396, Q496, Q197, and Q297. And this is obviously 43, 44, 45, 46. Just a continuation of the previous numbering. As you can see, Q296 ended at 42. So it starts with 43. So this is quarter 3. So it will be 0, 0, 1, 0. This will be 0, 0, 0, 1. This is 1, 0, 0, 0. And this is 0, 1, 0, 0. Okay, so we create this new data set says forecasting data set. And so we don't add at the end of this original file, but we create a new spreadsheet says forecasted data set. Now, this name can be anything. You can just say sheet 2, doesn't really matter what name you give to this particular spreadsheet. So, as I mentioned in class, when we compare models, when we explore to get the best forecasting models, we have to use the partition data. So in a partition data, you have the training set, which is used to train the different models. And then you have the validation set, where you compute the RMSE or any kind of error measure for the models when it fits or predicts values for this validation set. So after you have selected your best model, in this case the best model is your exponential model with seasonality, you want to actually now test or predict the next 4 quarters or your forecasted window to a completely new data set. Okay, when you do this, you do not use the partition data, but we use the original file, which includes both training and testing, training and validation data sets. So what I will do is, now I'm going to predict this new the values for these 4 quarters. I'm going to go to predict multiple regression. I will make sure that this data source is sheet 1. Okay, I want to first use it for everything. My dependent variable is log sales. My independent variable is time t to Q3. Then I'll go next. Now I will do a trick. Now, as I'm only using the original data file and not the partitioned spreadsheet, you can see that the score validation data is all grayed out. So I'm going to click on the fitted value here. I'm going to click on detailed report under score training data. And now I'm going to say that score new data in a worksheet. So I'm going to click that particular window box. When I click on that particular box, you will see this new in this new window. In this new window, you have to identify this new the spreadsheet you have created, which is forecasted data set, as your data source. And next thing you will do is you want to tell the program to match the variables in this particular spreadsheet, forecasted data set, with the variables that are available in your input data, which is in sheet 1. So best thing is to click on this match by name. As soon as you do that, it automatically compares and tells the program that the T in the forecasted dataset spreadsheet is the same T as it's in the sheet 1. And you click OK. Okay, and then you come back to this particular window and you click on finish. As soon as you're done, as you can see is you're going to get the RMSE. Now, once again, this RMSE is only for training because we have already decided what model to do. We are just now predicting the next 4 quarters. So the results will be under ML new score. So any spreadsheet that says new score, that's where the values are. So this is your new values for the 4 quarters you have and we have just predicted. So in order to now plot everything together, I'm going to copy this 4 values, go to the training score, and then I'm going to add those 4 things at the end. Okay, and then I'm going to plot these 2 things, predicted and actual, and will show you how the model did. So now you can see the model performed very well until the predicted, and then it also went ahead and predicted the next 4 quarters. And you can see that because that we have used an exponential model and control for seasonality, the new values actually maintain the same data structure as the values which are in the training set. So this is a great way, obviously, to predict using an XLMine, and obviously developing a linear model with our Coca-Cola sales data. Thank you for listening.